Alright guys, today's lesson is going to be on section 7.3. This is talking about logarithmic functions as inverses. Well, a logarithmic function is an inverse of an exponential function. So that's the very first thing we're going to look at, is how to change from one to the other. So we start out over here on the left with an exponential equation, n equals b to the p. You know, in most of the last examples that we've done, it's usually written like this: b to the p is equal to n. That's the way it is in most of the problems we've worked with so far. Your book just changed it around for this problem. Okay, n is just a number. This is your base being raised to a power. So now to change that to exponential, from exponential form to logarithmic form, here's what you're going to do. You're going to write the word log, and then your base, that was your base over here for your exponent, is now the base as a subscript for your logarithm. So the base of a number is going to be equal to the power. Okay, and the way that you read this logarithmic equation would be to say p equals the log base b of n. So now, in this box, your book gives you some specific information you need to know. It starts out basically telling you what we just did here. But it also tells you that b has to be greater than 0 and b cannot equal 1. Okay? Just like with our exponential functions that we worked with in section 7.1 and 7.2. Remember, in 7.1 and 7.2, they looked like this. And in that case, remember, b had to be positive and it could not be 1. Well, the same rules apply here. Okay. So then, once again, they tell you can read log base b of x. Here they give you the words for it. Okay. So now, let's take a look at problem number 1 here at the bottom, where they just want me to change to logarithmic form. Now, my brain has to work really hard to change to logarithmic form. It works much better when I have to change from logarithmic to exponent form. So I have to do this the exact same way every time, or I mess it up. So I always start out with the log, and then I do the base that was my power, and then equals, and I put my exponent over here. So log my base 10, there's my power, and then I fill in with my number. Okay, and I do it this way every time, or like I said, I mess it up. Some of you may have an easier time changing this than I do, but I have to really work at it. Okay, so once again for part B, I'm going to write log, my base is 3, my power goes over here, and then I fill in with the 81. And that's read as log base 3 of 81 is equal to 4. All right, so now I've got some examples for you to try. Okay, in this got it question, you may need to pause the video so that you can try those 3 on your own. I'll try to give you just a minute before I put it up here, but you may need more time, so if you need to, pause it, and then you can check yours with mine in just a second. Alright, so for part A, I'm going to have the log base 6, my power goes over here, and I fill in with the 36. Same thing for part B. log my base is 2/3, my power is a 3, and I fill in with 8/27. And then for part C, my base goes here as my subscript, my power goes on the other side, and I fill in with a 1. So now, with problem 2, we're going to learn how to evaluate a logarithm. And, there are several different ways to do this, and we're going to learn about them over the next couple of sections. But for today, in this problem, what we're going to do, when they want to know the value of log base 8 of 32, I'm going to rewrite this. And I want to know the value of that. I want to know what it is equal to. So I'm going to set it equal to x, because that's what I'm looking for. I want to know what is this stuff equal to. And then I'm going to change it back to exponential form, because that's what we are used to working with. Okay, we worked with that, for several sections. We worked with it in previous chapters. So here's where we're going to start. If I'm going to change from logarithmic to exponential form, here's how I do it. And again, I do it the same way every time, but my brain likes it better this way. I'm going to start out bringing this number straight down, equals. And then on the other side, I'm going to do 8 to the x power. And now I've got to figure out what x is. Well, what I'm going to do for this problem, okay, let me write my steps over here. Step 1, I set log base 8 of 32 equal to x, or you can use any variable you want. Step 2, I changed it to exponent form. And then, to actually solve for x, what I'm going to do is I'm going to rewrite 32 as a number to a power, and do the same with 8. And what you're going to try to do is you're going to try to use the same base. So when I'm trying to rewrite 32 as something to a power, well, the only thing I can come up with is to change 32 into 2 to the 5th power. On the other side, my 8 can be rewritten as 2 to the 3rd, but then I've got to bring my exponent of x straight down. So while this side stays 2 to the 5th, on the right, when you have a power to a power, you're going to multiply them. And now, if I have a base of 2 on both sides, basically what you're going to do is ignore the base and set the exponents equal. Okay, but you can only do this if your bases are the same. Because if this is 2 to the 5th power, it's got to be equal to 2 to the 5th power over here. So this 3x has to be the same as 5. So I'm going to write down 5 equals 3x. Now solve for x. X equals 5/3. All right, so the value of the log base 8 of 32 is equal to 5/3. That's the value they were looking for. And now, if you need to pause it to finish that up, go ahead and do so. But now I'm going to slide down to the bottom, and there are 3 that I want you to try. So I'll give you a minute or so to get started, and then you may need to pause while you finish the 3, and then I'll work them here. And then you can let me know next time I see you in class if you have more questions on it. All right, first I'm going to change it to exponent form, bring the 125 down, equals 5 to the x. Then 125 can be rewritten as 5 to the 3rd power. I can't rewrite 5 as something to a power, so I'm just going to leave it 5 to the x. But it just so happens my bases are the same, so ignore your bases, set your exponents equal. So the log base 5 of 125 is equal to 3. That is your answer. All right, now for part B. Set it equal to any variable. I'm going to use a y this time just because. You don't have to. And I'm going to bring the 32 down, equals the base to the y power. Well, just like in the example we did above, 32 is the same thing as 2 to the 5th. Well, I need to rewrite 4 as 2 to a power. So 4 is 2 squared. And don't forget to bring your exponent of y straight on down. So now, on that right-hand side, a power to a power, you multiply them. So I end up with 2 to the 2y. My bases are the same, so I'm going to ignore them and set my exponents equal. Now I can solve for y. Y is equal to 5/2. So what that tells me is that log base 4 of 32 is equal to 5/2. Okay, this is the value they were looking for. All right, and part C, you have to work a little bit harder for this one because of the fraction in there. So let's set it equal to a variable. I'm going to use an a this time. So I'm going to bring my 1 over 32 straight down. That's going to equal 64 to the a power. Well, I need to rewrite this 32 as something to a power, okay? Because I can rewrite 1 as 1 to any power, so that's not my problem. My problem is the 32. So I'm going to rewrite it as 2 to the 5th, just like we've done for the last couple of problems here. 64 can be rewritten as 2 to the 6th. And then remember, bring that a exponent straight down. So now, since I have a fraction on this side, but not on this one, I need to kind of make them look the same. So what I'm going to do is I'm going to move this up so it's not in a fraction anymore. But what that does is that gives me a negative exponent. And then on the right side, multiply my powers. And now I have the exact same bases. Neither one's in the bottom of a fraction. So I'm going to ignore those bases and set my exponents equal. So a equals -5 over 6. So the log base 64 of 1 over 32 equals negative 5 over 6. And again, this is the answer, the value we were looking for. All right, and we're going to stop this video with that example. And I believe I'm going to do 2 additional videos for this section, just to kind of break things up and keep them from being too terribly long. So, hope it helps. If you have questions, let me know.